Section 6.1 is titled Polynomials. In this section we'll look at how we identify, evaluate, add and subtract polynomials. Also we'll look at a lot of vocabulary, talk about how we classify polynomials. And then we'll also look at some basic operations of polynomials as well. We begin with some vocabulary. A monomial is a number or variable or product of number and variables. Key is there's no addition or subtraction. Monomial is a single term, which means no addition or subtraction. Everything would have to be multiplied together. Now we talk a lot in this section about degree. Degree of polynomials, degree of monomials. The degree of a monomial is the power of the variable, or the sum of powers if more than one variable. Okay. And then a polynomial, very simply, is the sum or difference of monomials. So it's polynomial where we're going to see plus and minus signs. In fact, poly means many. So it has many terms, which more than one. Standard form of a polynomial would be one in which the terms are written in descending order. And let me be more specific. Descending order by their degree. Okay. Descending order, what that means is highest power to lowest power. Okay, so typically whenever we write a polynomial expression, equation, function, etc., we're typically leading with the highest powered term and then writing the terms in order down to the least powered term. Now let's talk about classifying polynomials, how we can name them, I suppose. We can classify them by degree. By degree, a 0 degree polynomial we'd call a constant. Okay, that would be just like a number. Okay. First degree would be linear. A linear is first powered. So 3x plus 2, that's linear. The variable term is first powered. Second power is called quadratic. Quadratic is anything that has x squared. So we have 7x squared plus 2x minus 1. That would be quadratic because the highest powered term is a second power. Third power we call cubic. Okay, so a cubic polynomial is anything that has its highest power as a third power. Say negative 2x to the third plus 5. That would be it. Doesn't have to have all the terms, just that the highest power is third power. Fourth power we call quartic. An example of that would be anything with the fourth power that's the highest term, like x to the fourth minus 3x squared plus 2x plus 8. That's a quartic polynomial. Highest power is 4. It's a degree 4. Now there are names for higher powers yet, but really I'm not going to bother you with memorizing all the higher powers than fourth. I would just call these nth degree. So for example, if I were to give you 3x to the 7th minus 2x plus 1, we would all just call this 7th degree, instead of worrying about a name for a 7th degree polynomial. So we can also classify polynomials by the number of terms that they have. A single term polynomial, one term, we've already defined. It's a monomial. An example of a monomial is anything with one term. 4x to the 6th. Single term, that's a monomial. Two terms we call a binomial. So x plus 4. So that's a binomial. Two terms. Three terms we call trinomial. Okay, so x squared minus 3x plus 1. Three terms, that's a trinomial. Anything larger than that, instead of giving specific names for, we just can call them polynomials. The prefix poly meaning many. So if there are more than three terms, polynomial will be just fine to describe it. Directions on these first two problems ask us to write the polynomial in standard form and classify it by degree and number of terms. So to get it into standard form, we want to lead with the highest powered term. So the 8x to the 4th comes first. Next comes the 3x squared. And at the end comes the minus 4. And then classified by degree and terms, I would call this a quartic trinomial. Quartic, as this is fourth powered, trinomial because there are three terms. The next one, to get it in standard form, that negative 9x squared has to come first. Plus 4 goes second. I would call this a quadratic binomial. Quadratic as it is second powered, binomial in that there are two terms. Next couple of examples are addition and subtraction problems. When we add and subtract polynomials, we need to add and subtract like terms. And since I want to put this in standard form, I'm going to look for the highest powered terms that I see first. I see x to the 3rd powered terms. So I'm going to add them. I have 2 here. I have 1 here. I am adding. 2 plus 1 gives 3x to the 3rd. Okay, after the 3rd power, I look for the 2nd power. And there's 1 right here. It's the only one in the whole problem, so there's nothing to add it to. It's going to have 5x squared. Next, I'm going to look for my x's. I've got negative 1 plus 7, which is 6. And then finally, I'm going to look for my constants, which are the terms that don't have x's. And I've got 9 plus 4, which gives me 13. And that's finished. Next example is a subtraction problem. I do it the same way as the other one. I'm just minusing instead of adding. I'm going to find the highest powered term first, which are these x squared terms. I've got negative 2 minus another 1 is negative 3x squared. Next, I'm going to locate my x's. This is the only x. We have to be tricky with the signs here. I am taking away a negative x. Subtracting a negative is adding. so plus x. And then I look for my constants. Got 3, take away 6, that's negative 3. Last problem is a story problem. It says the cost of manufacturing a certain product can be approximated by the function below, where x is the number of units of the product in hundreds. Evaluate C of 0 and C of 200 and describe what the values represent. So C of 0, I'm putting 0 in for the x's. That of course is 0, 0, so the answer is just 45. So what does that tell me then if I'm going to interpret this answer, that the cost to produce 0 units is $45. Okay, so there is some cost to make nothing. Maybe there was equipment cost, etc. So it does cost something here to make nothing. Next example, or the next part of this problem, find C of 200. So I want 3 times 200 cubed minus 18 times 200 plus 45. I'm going to go ahead and take a moment and do this on the calculator, as the numbers are a little large. I don't want to mess up. Okay, I get, it's a rather large number, 23,996,445. Okay, so the interpretation of this would be the cost to produce, now it's not 200 units. Notice X is the number of units in hundreds. So it's 200, 100. That's 20,000. Cost to produce 20,000 units is $23,996,445.